Thank you, everyone. It's always a pleasure. It always feels incredible to be here. As someone knows from the organization, my very first conference as an attendee was in JSday in 2016, I guess. So it's always an honor to be here, both as an attendee and as a speaker. So thank you so much for having me this year as well. And today I'm going to talk about a full-text search engine that I wrote, first as a joke, then as a little more serious project, and now as a company. So this is where we are going to lead by the end of the talk. And I want to start talking, if it works, yeah. I want to start talking about Elasticsearch for a very specific reason. How many of you knows Elasticsearch? Awesome. How many of you uses it? Amazing. I'm not going to ask how many of you are happy with it because no, I was serious. I mean, I like it. I love it. And that was the project that got me into open source software in the first place. And the reason it's pretty obvious. I mean, I've been working on Apache Unomi, which is a customer data platform. And it was incredible. It used Elasticsearch as a leader database in its infrastructure and architecture. And we saw pushing millions of records every single day against Elasticsearch, and it was just going fine. And I wonder how is that possible? I mean, it feels like magic that having billions of records can lead to such incredible performances, right? That feels literally like magic. And I dig a bit into how full-text search engines works, and I discovered that Elasticsearch, it's not actually a full-text search engine. Instead, it wraps Apache Lucene, which is a free and open source software built in Java, which is the actual full-text search library. And Elasticsearch provides a RESTful interface to it, distributed system capabilities, sharding, data consistency, monitoring, cluster management, whatever you can dream of. Elasticsearch can provide it to you. So big shout out to Elastic for that. And before we proceed, I want this to be very clear. I love Elasticsearch. And the very reason why I started doing something a bit different was because I wanted to learn more in the first place. Like Richard Feynman says, what I cannot create, I do not understand. That's how I learn. And also, I had some little issues with Elastic. So as I said, I love it, but still I had some little problems, like Elastic, it's not easy to deploy to me, it was hard to upgrade, it has a big memory footprint, CPU consumption is becoming more and more important as you scale, it's very costly to manage and run, hard to extend and customize, and Java, right? Yes, that's the biggest problem I had with it. I know there are other search engines in the industry, like Algolia, which again is a product I deeply respect and love, but still I had some problems with it. So it's incredibly expensive at scale, even more than Elasticsearch. It's a big black box because it's a closed source software, so you can not understand what's going on, and it's really hard to extend. Also, Algolia is written in C++. It's not really easy to get into how C++ works, right? When compared to JavaScript or Java. I mean, so maybe the first time I approached those search engines, I was too inexpert, and Elasticsearch and Algolia were a bit too much for me. But still, I believed in making simple software. Though it's hard, it's something we all should strive to, right? So I set myself some goals, because the only way I can learn is by setting some goals. So I wanted to give a talk on how full-text search engines works. So I had to study a bit how they work. And I wanted to create a new kind of full-text search engine and make it easy to adopt. And I want it to be massively scalable and easy to extend. And of course, I started digging into the theory behind full-text search engine. And when you dig into the theory that powers full-text search, you have to deal with trees, graphs, n-grams, causing similarity, BN25, TF-IDF, tokenization, stemming, and more, and more, and more. We already saw this slide with the gift presentation. I think this is pretty cool, because that's literally how we work as developers, right? And yeah, so that's really it. I started to learning more about full-text search engines. And I discovered a hard truth that if you want to do something like that, you have to study algorithms and data structures, and you have to study a lot. And of course, you need a programming language to implement them. And I wanted to be a cool guy, right? I wanted a strong and powerful programming language. So I saw people reacting like this when the Haskell logo appeared on screen. That's a joke. I wanted to be a cool guy, so I started implementing in Rust. But being a cool guy and being a good Rust engineer, it's not always the same thing. I mean, you can be both. I'm not both. I'm not either, actually. So I said, no, Rust is a bit too much for me. Maybe I'll go back to Golang, garbage collected, but still strongly typed. And then I remembered Jeff Oatwood, the co-founder of Stack Overflow, talking about the Oatwood load. So any application that can be written in JavaScript will eventually be written in JavaScript. I truly believe that. And then I choose JavaScript. Woo! And one thing I discovered when migrating my code from Rust and from Go into JavaScript is that it was pretty fast because I respected algorithms and data structures rules. So I believe, and I want this to be the first takeaway from this talk, there is no slow programming language. There is just bad algorithms in data structures design. And I'm going to prove this in just 1 second. Let me give you an example. So one common problem you have when you work with search engines is that you have to run Boolean queries. Or, and are just examples of Boolean queries. So if you have multiple arrays of document IDs, scores, etc., you have to compute the intersection. So tokens that appears on every single array. So this is an example of a bad array intersection algorithm. Let's call it version 1. So we basically use MapReduce paradigm for trying to find the intersection between an unknown length of arrays, an unknown amount of arrays of an unknown length. But we can optimize it, right? We can strip away the MapReduce paradigm. We can use iteration. But I'm not sure this is the best way to do it. We are missing just one little piece. So we should start sorting from the smallest array first, because if the smallest array is the number 1 we're going to look through, this is where we are going to find the conjunction of the intersection of all the sets. So I made some benchmarks, and I discovered that throwing away all the MapReduce stuff, which is highly optimized, but not as optimized as loops and iterations, well-made loops and iterations, we have a 13% increment of performances. And why is that important? That's a PR that for a project that is super secret, but we're going to see that in just a second, that proves how this PR introduced a 50% increment in performances just by the way we basically computed the intersection between arrays. And of course, another takeaway that I want to give you is that you have to know your language and how to optimize it for your runtime. So just talking about runtimes, who is using Node.js here? Awesome. Who's using Dino? Awesome. Oh, come on, try it. It's worth it. Who's using Bun? 1.5. All right. Try them. I mean, it's worth trying. They all give you different takeaways. But now I will be just concentrating on Node.js, which is the one I actually use the most. There are many routes you can follow. Wow, it's pretty bright, I see. There are many rules that you can follow when talking about optimizations in JavaScript. One easy example is polymorphism versus monomorphism. So if you have a function that takes multiple arguments and you always pass the same arguments of the same type, the V8 engine is going to optimize for them. And this is one nice way to speed up your code for free. So instead of saying, I can use a function for concatenating both string and compute addition between numbers, I can just create 2 different functions like add numbers or concatenate strings. They do the same thing. They use the plus operator, but there are 2 distinct ways of optimizing your code. That's just a simple example. There is an entire repository, and I would prompt you to take a picture of this slide because you're going to find the link for the repository here. And this is an entire set of rules that you should follow if you want to optimize your Node.js code. This is written mainly for V8 engine and for Node.js specifically, so I highly recommend you to take a look at this. There is just an example I want to show you. Who's familiar with TooFast properties library? Awesome, yeah, I knew that, Nicola, of course. But too-fast properties, it's an amazing library because it's really simple. So you know that whenever you go modify the shape of an object in JavaScript or on the V8, you're basically lowering the performances for a very simple reason. Every time you have to compute, you're modifying the reference of a variable, and every time you have to access it, it basically has changed. So you lose your optimizations. So too-fast properties does something pretty good. Can you spot it? Take a look from line 24 to 27. It basically loops 10 times, calling the function without arguments, and that heat ups the inline optimization of the V8 engine. Did you know that? I see people face palming right now. And I do understand why. That's crazy, right? But this is the kind of stuff that you have to learn if you want to go in the microseconds area, and we are getting there in just 1 second. Once you know how to optimize it, as I was saying, JavaScript is very, very performant, and these are the rules that you have to follow if you want to optimize it. And how do you know which rules you should follow? That's pretty simple, actually. Experience, break stuff, try again, and go read the open source libraries, because this is how you will find very nifty tricks. And once you optimize your code, as I was saying, you can make it work easily in the microseconds area. And when you think of microseconds, maybe you think about C++, C, maybe Golang, Rust. JavaScript is one of those languages we should put in the list, not Java, JavaScript. No. I'm sure you can also do that with Java, but I don't know how. So, as I was saying at the beginning of the talk, I gave myself a goal to give a talk about full-text search engines, and I did that at World Congress 2022 in Berlin. That is the biggest developer conference worldwide, like 8,000 developers altogether, and I gave a talk on how full-text engines works. And I made a small prototype, and you have to know that at the time, I was working at Nearform, and I was working there in a very special team called the Developer Experience Team, led by Matteo Collina, that everyone knows, and I know it's around. We had people like Paolo Insogna, a Node.js core contributor, Rafael Silva, which is Node.js TSC member, and Cody Zuschlag, professor at the NS University part-time, other part of the time, working with us at Nearform. So that was a pretty strong team, and I asked them, please help me optimize this, because I'm sure you know how. And eventually, we optimized it, decided to open source it, and we open sourced it with the name of Lyra. We had some problems with the name Lyra, actually, because there is a Google codec called like that, many companies called like that, so we will see later how we solve that problem. But some guy took the link for the Lyra project and put it on Hacker News, and we've been in first position for 2 days in a row, and that led us to like 5,000 stars on GitHub in just 1 week or so. And we said, hey, you know what? Can possibly build a product around that. So I took the best people I could from Nearform. I took Angela, which is here, our now head of design. We got Paolo, Node.js core contributor, and now principal architect with us. I stepped in to work on the search engine itself, but we still were missing one person that we kept secret until today. We needed a person with business knowledge. We needed a person that also knew how to deal with, startups and stuff like that, because we wanted to build a product around it. So we introduced Sir Isaac Roth, so author of OpenShift, founder of StrongLoop, CTO in IBM, and now CEO and co-founder with us at Orama, the company that we built to disrupt, possibly, full-text search with JavaScript. So, thank you. So if you had experience with Elasticsearch, you might know how it works, right? How many lines of code does it take to spin up a Elasticsearch cluster? You might be thinking, in what language, first of all? Like Terraform, YAML files, Docker, I don't know, a lot. This is how much it takes to create a new database with Orama. So you just create a schema definition. You only index the properties that you want to index and then search through. So let's say a movie database, like title, director, and some metadata like rating, which is a number, and has won an Oscar, which is a Boolean. And when I was talking about algorithms in data structures, every single data type, every single thing that you're seeing here has a very specific data structure. Like we had, of course, radix trees for strings, AVL trees for numbers and black-red trees for Boolean values, or we actually provide an opaque interface so you can use your own algorithm or your own data structure, and you can use our test suite to test if they are working properly. So if you need a project where you want to test your skills in data structures, just use Orama and maybe send a pull request. That's what I ask. So yeah, we just created a new database. Now we need to insert stuff like my favorite movie ever, The Prestige. Who knows The Prestige? Wow, who thinks that's the best movie ever? Oh, come on. Come on, we have David Bowie in this movie. Do you realize this? Okay, anyway, that's a rant for another day. So let's insert some data. As you can see, we are moving the database, which is basically a JavaScript object, as a first argument of our insert function. Why didn't we use classes? That's an optimization. Because every time you actually call the insert method, or the insert multiple, which basically inserts batches of documents into your database, that's something that we discovered it's a faster way for dealing with insertion of data instead of using mutable classes. Once you insert your data, you just have to query for them. So basically, you use the search method, look for prestige on the properties, title, or you can use an array of properties you want to search through, or you can use the star operator to search through all the properties that you have. And now you might be wondering, like, okay, we got mini search, flex search, Fuse.js. These are all amazing products. Believe me, these are beautiful products. So what does make Orama so special when compared to them? Well, we have a huge feature set. First of all, we have support for facets, filters, typo tolerance, file boosting, stemming, stop words, plugins, components, and hooks. If you're thinking of React, this is not React. I left them for last for a reason. So you can basically hook into the compilation process and the indexing process and the search process with your own code. You can extend Orama by using its own APIs and opaque interfaces for building your own data structures using, for example, components. Or you can say, okay, you know what? I'm building a database specifically for Michele, for example, who loves the Prestige. So whenever he searches something on Orama, we are going to boost all the movies that are similar to the Prestige, for example. And you can do that with hooks. You can create custom indexes for every single person in your organization or on your product. It also works wherever JavaScript runs, because it's written in JavaScript, of course, with no dependencies at all built from scratch. So it works on Cloudflare workers, for example, works on Dino, on Ban, on React Native, on Flutter, Node.js, of course, browsers, it works everywhere. And it's extendable in plain JavaScript, just like I said. And it's also insanely fast. And don't believe me? Maybe we can do a little demo. I'm not sure it works. We can try, right? Let's see. Wow, it disappeared. Awesome. Let me know when I'm on Chrome. Oh, yeah, I'm on Chrome, but on the wrong. OK. Give me just 1 second. Here it is. Fantastic. So what I'm going to do right now, this is a small demo with 20,000 products took from Flixcard.com. So this is a real catalog of an e-commerce store with 20,000 products, including title, description, metadata, prices, whatever. And I'm going to index them for you in real time on the browser directly. So whenever I'm clicking on this, we're going to index in 20,000 full products. It should take about 3 seconds, which is nice, 20,000 products in 3 seconds. And now we're in a situation where we can either use our browser as a source of truth. Like Algolia, you know the pricing. You know that you pay for every single query that you make. Here, you're not paying. But if you notice here, use local index. What does it mean? That we deployed whatever you're looking at also on a global and distributed CDN, which is our own CDN. So the cost of running a query is like the cost of fetching a GIF from a CDN. And that's insane. Let me give you an example. Let's search for blanket. All right. How much did we take on a global CDN? OK, 72 702 microseconds. So if you're deploying this on AWS Lambda, this is the price that you're gonna be invoiced for. Actually, you'll be invoiced for 1 millisecond because that's the minimum that AWS can invoice you. But we can grant you that you're not gonna pay more than that. Also, please know that we're deploying this on our own CDN, and you know that you pay your CDNs by the egress data. And this is how much you paid for the images, 10 images that you see. This is like 1.5 megabytes, if I see correctly. But you're also paying, as a comparison, 5 kilobytes for the payload. So you pay 5 kilobytes plus 1 millisecond of execution. And of course, if you use the local index, now it's taking, a bit more, surprising. It depends on many things, but like 800 microseconds on the browser to find 140 results out of 20,000 documents, but you're not paying anything at all because the search is local. So that's what makes Orama different. And you can try. I will be publishing the demo sooner or later, so I guess you can try it on your own. So, Orama Search, at its core, it's cheaper, better, faster enterprise search. And you don't have to deal with cluster management like you did with Elastic or Meilisearch or whatever. You don't have to deal with server provisioning because the CDN scales for you, right? You don't have performance degradation because you run everything either on the browser or on CDNs, and it's as simple to use as a JavaScript library. This is what makes JavaScript especially cool to me. And it's the fact that this is only possible thanks to JavaScript. But that's not all. If you'll be following Orama Search on Twitter, Instagram, whatever, I will be putting a QR code in just 1 second. You will see that sooner, you will be able to integrate your own large language model and let Orama do its magic for you. That's ChatGPT, which is not really blocked in Italy, but we can discuss this later. Right? So, not only you can have, if you have like 1,000 clients on your e-commerce, you can build 1,000 different indexes for each one of them and target every single user. You can also use your own large language model to do that. And that's really it. I would prompt you maybe to follow us, give us a star on GitHub and follow us on Twitter. We also have a mailing list. No spam, I promise. So I would really love to have some of you signing up from this very link. And most importantly, before I start, we are also hiring. We're hiring full remote, and this is all public. I mean, this is how much we can give you. And that's really it. Thank you so much for having me. It has been very fun.
Thank you so much. It must be very exciting to make something like that from scratch.
Yeah, thank you.
Are there any questions? No question. Oh, there. Yeah.
Thank you. That was an excellent presentation, and also a great job on all the turbofan optimization. That's a great challenge. So I have a question about the LLM use case specifically. Which sort of, let's say, sentence transformer models are you sort of like planning on supporting, and can you bring your own? So, because what we found is that, you know, the performance for different use cases depends so much on which transformer model you use. So can we use Orama and bring our own?
Absolutely, you're very right. The problem with LLMs is typically performances. You're very right. If you think of like ChatGPT-4, it's superb, but it's really slow. But one thing I forgot to mention maybe is that Orama is immutable because you're deploying to a CDN. So it means that you can pre-calculate everything you need. So you actually pre-calculate a delta of all the things that can be important for your users and just deploy it as part of your index. That's really it. You solve the problem.
Any other? Oh, yeah.
Hi, I don't know much about like deep optimization for JavaScript engines, but my question is, in non-V8 environments, how well it performs?
That's a very good question, actually. For example, too fast properties breaks on JavaScript core. So if you're using Bun, for example, or you're using Safari on iPhone, for example, that's pretty used. You don't want to do that kind of optimization. There are other optimizations that works in a certain way, like, for example, instead of using stateful classes, just pass an object through your monomorphic functions. This is how JavaScript works, so you can basically do it wherever you want. There are certain optimizations that targets specifically a runtime, like too fast properties, for example. And of course, whenever you don't have that runtime, it will fail, or worse, it will go a bit slower, and that's the case. So my belief is that, for example, we used that on Orama. We found out that on Safari it wasn't performing well. So either you decide, okay, I'm on Safari, I will just keep that and I will be applying a different optimization, or you remove it completely. We decided to remove it completely because it wasn't really worth it for our use case. But like, when I asked how many of us are using Node.js, almost everyone is using Node.js. Of course, we're at a JavaScript conference today. So if you have the specific need for a server-side service optimization, then you can just say, yeah, you know what, this is just running on Node.js, so whatever. that's like, it's always a trade-off, you know, and I believe there are cases where this is very convenient.
All right, thank you so much.
Thank you all.